All right, time for lesson 5.5, direct variation today. Let's look at a little situation that has direct variation in it. So, as you watch a movie, 24 individual pictures or frames flash on the screen each second. Okay? So when you're watching, there's a lot of images going through per second. Here are 3 ways that you can model the relationship. So we have talked a good bit about tables, graphs, and function rules, and all 3 of these are ways to represent the same thing. So that I've already done them for you, so we don't have to waste a lot of time. Function rule f of s equals 24 times s. A graph, it's going to look like this straight line going up by 24 every time. And here's our table. You can see that there's 24 frames for every second. So what I want you to look at, I want you to try to answer these 3 questions before I say the answers. Go ahead and pause the video and then we'll talk about them. Okay, so the first one. As the number of seconds doubles, what happens to the number of frames? So I want you to look at the number of seconds doubling. So let's look from 1 to 2. As it goes from 1 to 2 seconds, I see it goes from 24 to 48 frames. There's a certain relationship there. Let's double from 2 to 4 now. From 2 to 4, it goes from 48 to 96. You're noticing a relationship here. I hope that you notice the number of frames also doubles. Okay. Second thing, find the ratio of number of frames divided by number of seconds for each pair of data in the table. So you're just doing like 24 divided by 1, 48 divided by 2, etc. If you do that all the way down, you should see that every single time we have that ratio of 24. We have a constant ratio. Keep that in mind. And 3, for every increase of 1 second on the horizontal axis of the graph, so every time it goes over by 1, what's the increase in vertical? So if I'm going to see how much is it going up every time it's going over by 1, here we'd have to do a little bit of estimation. But I know because of using my table too that it's going up 24 every time it goes over 1. Okay, so it's going up 24 frames. Okay. And if I want you to notice that we noticed that the ratio was 24 for the table and 24 for the graph. And I want you to see that in the function rule, lo and behold, here we still have this 24 multiplying our seconds. Okay, this was a specific example of a direct variation. A direct variation is a function. It is always in this form, y equals k times x, and k does not equal 0. So y equals kx, that's the equation that we're going to write for a direct variation. K is known as the constant of variation. So notice when I looked back at this table, I said, hey, when you divide frames by seconds, you always get this constant ratio. That ratio, in that case, would be 24. That's our value of K, that constant of variation. And something that you have actually encountered before is talking about this proportionality, when things are proportional. If a function is a direct variation, x and y are directly proportional to each other. They're always directly proportional to each other. I want you to think about this. Pause the video because I am going to say the answer in a minute, but I want to see if you can come up with it. If a function is a direct variation, what will its graph look like? So think about the equation. Think about that relationship and being directly proportional. What do you think it will look like? Okay. I don't know if you came up with these things, but it's pretty important. Its graph is going to be a straight line. So that's one really important characteristic. And the other thing, it's always going to be through the origin. It's always going to pass through the point 0, 0 on the graph. So if a graph does these 2 things, it's a straight line through the origin, and k does not equal 0, so we're not going to have it be a vertical or horizontal line. But other than that, straight line through the origin, that tells us that that's going to be a direct variation. Okay, so when we're looking at equations, and I want you to notice if the equations are direct variation, what you're trying to see, will they make a straight line through the origin? Can you get them in this form, y equals kx? Okay, and if so, find the constant of variation. So usually if I'm trying to figure out if something is a direct variation, I try to get y alone. So I typically just solve my equation out by doing the same thing to both sides. So I have 3y equals negative 2x. Obviously y is not alone there. So if I have 3y equals negative 2x, I would divide both sides by 3. And this looks like y equals negative 2x over 3, or y equals negative 2/3 x. We will probably often write it. Okay, so we're looking at this new equation, y equals negative 2/3 x. And we want to say, is this in the form y equals kx? Yes, it is. Absolutely, it's in that form. What's the constant of variation? The constant of variation is the number that's replacing k. So the constant of variation, k, is negative 2/3. Okay, try this one, the second one on your own. All right, 3x minus 4y equals 5. Okay, so again, I'm going to be trying to get y alone. I would subtract 3x from both sides. And then I have negative 4y equals, I'm going to write this as negative 3x plus 5, just to get it in the right order that I like it in. And I'm going to divide both sides by negative 4. And I could just write y equals negative 3x plus 5 over negative 4, but if I'm really trying to see if this is in the right form, I'm probably going to want to divide each part out. So negative 3x divided by negative 4, that's just going to be 3/4 x, because the negative divided by a negative is a positive. And then 5 divided by a negative 4, that's going to be a negative 5/4. So I'm going to write this negative 5/4. So now what I'm looking is this in the form y equals kx? And what I hope you notice is that there's this little extra thing in here, this minus 5/4. So if you graphed it, if you remember back from last year, that would not be going through the origin. Okay, it would be a straight line, but it would not go through the origin. So therefore, we're going to say that's not direct variation. Okay, so it's no. Because of that negative 5/4, it's not in the form y equals kx. It has a little something extra in there. Okay, so what you're going to notice here, you're going to try to write an equation of the direct variation that includes these points, 4, negative 12. So if a graph includes 4, negative 12, so it's going to be somewhere over here, and it's to be a direct variation, it also has to go through the origin. So it's going to be a straight line going through that. So you can notice there's only one line that would actually go through that. And we know our form has to be y equals k times x. So basically what you're trying to figure out is y equals what number times x. I hope you guys remember, from elementary school to undo the opposite or the inverse operation of multiplying is dividing. So if I figure out what negative 12 divided by 4 is, what y over x is, oops, it's positive 4, that's going to equal negative 3. That should tell me that y equals negative 3 times x. And in this case, does negative 12 equal negative 3 times 4? Why, yes, indeed it does. So this is my equation. So all you're trying to do to find the constant of variation, just like we did in that original rate table back in the first slide, all I did is divide my y divided by my x value, and that gave me my constant of variation. So when I'm looking here, I just did negative 12 divided by 4. That gave me negative 3. That's my constant. Okay, so this one, the 0.57, okay, so again, it's going to have to be a straight line through that point. If I kind of put a little 5,7 on there or something, graph it through. There's only one line that it would work again, and I know it's going to be in the form y equals kx. You try writing that on your own. See if you get it. Okay, and so to find k, I'm just going to do y divided by x. That's going to give me my constant. 7 divided by 5. I can either write it as 7/5 or 1.4. I'll take either one. So I'm going to have y equals 1.4k or just y equals 7/5 k. These are both good answers. I like them both. Okay. All right, here's like a real life situation. The weight of an object exerts, or the weight an object exerts on a scale varies directly with its mass. If a bowling ball has a mass of 6 kilograms, the scale reads 59. Okay, interesting. What I want you to do is write an equation for the relationship between weight and mass. Okay, so again, I'm probably going to look at this constant of variation here. I'm just going to call my mass x in my the scale reading y. So it's looking like it's going through this point 659. I want to find my constant of variation. So I'm going to do 59 divided by 6. And I'm going to get 9 and 5/6, or 9.83 repeating. Okay. So that looks like that's going to be my K, my constant of variation. So if I call my scale reading Y, Y is going to equal 9.83 repeating times X. Okay, something like that. And leaving that as 59.6 is also okay. Y equals 59.6x. That might make you solving your next two problems easier, depending on how you like to work your calculator, etc. Okay, so here's this problem. If a bowling ball has a mass of 4 kilograms, what will the scale read? So I can do this many ways, but one way I can do it is work on my equation that I just created. So my equation said y equals 59.6x, and I know that my x is 4 kilograms because that's my mass. So y equals 59.6 times 4. And this, let me just give you a tip on using the calculator to help you with that. Okay, so anytime you want to use a fraction in a calculator, you just use the division sign. So if I wanted to do 59 divided by 6, okay, and I could hit enter there, and then times 4, so I put too many times symbols in there, so that's not going to work out too well. Let me see if I can get on there. Okay. There we go. Let's delete that up. So answer times 4, enter. And then I see I got 39.33 repeating. I don't want you to just try to round 9.83 and then times 4. You won't be as precise because we can see it's exactly 39 1/3. So this is going to be 39 1/3 or 39.3 repeating is what the scale is going to read. And we don't have a unit for that, so that's all we're going to leave it for now. Okay, last one. If a scale read 118, what is the mass of the bowling ball? Try to solve that one on your own. This time I'm substituting 118 in for y. So I have 118 equals 59.6x. And remember that to undo multiplying by a fraction, we can multiply both sides by its reciprocal. So I'm going to multiply both sides by 6 over 59. Okay, and I should notice that, well, maybe you notice 59 times 2 is 118. So when we're doing this, this is kind of nice with these cross cancel. It makes a 2 and a 1. And 6 times 2 is 12. So I just get that the bowling ball is 12 kilograms. Okay. So that's a good real life problem with this. All right. So a lot of times we're going to look at a table, and I want you to just see if the ratio y over x is a constant to say whether or not y varies directly with k. If it is direct variation, make up an equation for yourself. Okay, you try this one on your own, see if you can get it. Okay, so basically all I'm doing is every time I'm dividing y by x, and here I get -1/2 or -0.5. Here I get -0.5. Here I get -0.5. Every single time we got the same ratio, so therefore it is a direct variation. My equation is y equals -0.5x. Okay. Try this one on your own as well. Okay, so on the first one, if I divide y divided by x, I get -2. Here I get 2, and here I get -2. You notice they are not all the same, so this is not direct variation. Okay. All right. All right, last science-like problem. Suppose a windlass requires 0.75 pounds of force to lift an object that weighs 48 pounds. How much force would you need to lift 210 pounds? Okay, so again, you can solve this in many ways. You can certainly write an equation that relates if you call pounds y and this x. So we could try to actually figure out a constant of variation here. Or you can remember that direct variation means directly proportional, and you can try to write a proportion to solve it, which is kind of like the method I prefer in a situation like this. So I'm going to do force over the weight. That's what I'm going to be comparing. So I'm going to have 0.75 pounds goes to 48 pounds. How much would go to 210 pounds? Okay, and then you can solve this proportion in any method of your choice, finding the scale factor, cross multiplying, whatever method you tend to like. But I'm going to find here that x equals 3.28125 pounds of force. All right, not even going to have time to say these last few questions, but here's what I want you to think about On your way out, you can pause, think about it, make sure you know the answer